Hi everyone, welcome back to my channel. So in this video, we will learn about Lex and Yacc function. So first let us see what is Lex. So why do we need Lex? For a C program, the units are variable names, constants, strings, operators, punctuations, and so forth. This division into units, that is, which are usually called tokens, is known as lexical analysis or lexing for short. Lex helps you by taking a set of description of possible tokens and producing a C routine, which we call a lexical analyzer or a lexer or a scanner for short, that can identify those tokens. The set of descriptions you give to Lex is called a Lex specification. So Lex is a tool or a software which automatically generates a lexical analysis, that is finite automata. It takes as its input a Lex source program and produces lexical analysis as its output. Lexical analyzer will convert the input stream entered by the user into tokens as its output. Lex is a program generator designed for lexical processing of character, input-output stream, anything from simple text search program that looks for a pattern in its input-output file to a C compiler that transfers a program into optimized code. So these are the Lex functions. Why Lex? So this function is main entry point of Lexer. It returns the next token found in the input stream. You need to define this function in your Lex program. Why text? A global variable that contains the matched text for the current token. You can use this variable to access the lexeme associated with the token. Why in? A file pointer that represents the input stream for Lex. By default, it reads from the standard input. You can redirect it to read from a file using reopen. Why out? A file pointer that represents the output stream for Lex. By default, it writes into the standard output. You can redirect it to write to a file using reopen. So now let us see Yacc. Yacc is a parser. So Yacc is a parser generator that generates syntax analyzers, also known as parsers. Yacc reads a formal grammar specification and generates code that performs parsing. Yacc uses context-free grammar to define the language syntax. So these are the Yacc functions. Why parse? So this function is the main entry point of the parser. It initiates the parsing process and returns the result. You need to define this function in your Yacc program. Why type? A type definition that represents the semantic rule value associated with each token. You need to define this type according to your needs. Val, the global variable that holds the semantic value of the current token. It is set by the lexer and used by the parser to pass values between tokens. Error, a function called on a syntax error. You can define this function to handle syntax errors in a custom way. So here is an example of Lex and Yacc program. So this is a program to print the Fibonacci series. So let us go through each line of the code and explain their purpose. So first, this is the lexer.l, that is the Lex file. So as we all know the structure of Lex program, it starts with the definition section and then rule section. Again, the rule section is having the pattern and action, and then we are having the C program subroutines. So in the definition section, so we are having the header files, that is y.tab.h, that is used to connect the Lex and Yacc program. So next in the rule section, so you can see the lexer.l file defines the lexical analysis rules using regular expressions. So here in the role section, 0 to 9 plus. So this matches a sequence of one or more digits and returns the token number. Next, we're having the /n that matches a new line character and returns to the token EOL, that is end of the line. And this point, this matches any other character and is ignored. So ignore any character. The YY wrap function indicates the end of the input. So here we can see the YY wrap. So that indicates the end of the input. And it returns 1. So now let us go to the Yacc program. So that is the parser.y. So the structure of Yacc is also similar to the Lex, where we have the definition section first. So in the definition function, we are defining the header files and some declarations. The parser.y file contains the grammar rules and the corresponding actions. So here you can see the token in the rules section. You can see the token number EOL. So declare the tokens using the grammar. And then we are having the %left plus minus and %left star and slash. Specify the precedence and associativity of the operators. The input rule specifies the overall structure of the input, and the line rule handles each line of input, either an empty line or a Fibonacci expression followed by a new line. The fib underscore expr eol. So this rule handles the Fibonacci expression, which consists of a single non-negative integer. And next we are having YY error function. So this is input on an error and displays an error message. The fib function, it calculates and helps us to print the Fibonacci series for the given number. Next, it initializes. So in the fib function, we can see it initializes A and B to 0 and 1 respectively, and prints them as initial values of the series. It then calculates the prints the remaining number in the Fibonacci series using a loop. The main function initiates the parsing process by calling y by parse. So now to compile this program, first we have to create a file. First we have to create a Lex program file using .l extension, and then write a code of the Lex program, and then we have to create a Yacc program file with .y as an extension, and then we need to compile it by using cc program cc lex.yy.c.tab.c as a command, and run the program with ./a.out command. So we get the following output. So input, if you give the input as 6, we get this Fibonacci series as 0, 1, 1, 2, 3, 5, 8. Thank you.